Welcome to this video on dilations, similarity, and introducing slope. Students learn to understand and use the term dilation and to recognize that a dilation is determined by a point called the center and a number called the scale factor. They will also understand similarity of plane figures in terms of rigid transformations and dilations. Students will use similarity of slope triangles on the same line to understand two distinct points on a line determine the same slope. Here are the essential vocabulary words that will be introduced in the unit: center of dilation, dilation, similar, and slope. Students will begin extending their understanding of transformations to include non-rigid transformations. Specifically, they will learn to make and describe dilations of figures. A dilation is a process to make a scaled copy of a figure and is described using a center point and a number, which is the scale factor. The scale factor can be any positive number, including fractions and decimals. If the scale factor is less than 1, the dilated figure is smaller than the original. If the scale factor is greater than 1, the dilated figure is larger than the original. In this dilation, the center point P and the scale factor is 1/2. When dilating figures, the distance from the center of dilation to the point on the figure is multiplied by the scale factor to get the location of the corresponding point. In this example, the distance between center P and B multiplied by 1/2 results in the distance between P and B prime. Notice also how the side lengths of the dilated figure A prime, B prime, C prime, D prime are all exactly 1/2 the side lengths of the original figure ABCD, while the angle measures remain the same. Students will also investigate what it means for two figures to be similar. Similarity in mathematics means there is a sequence of translations, rotations, reflections, and dilations that takes one figure to the other. When two figures are similar, they are always many different sequences of transformations that can show that they are similar. Here's an example of two similar figures. If we needed to show that these two figures are similar, we can first identify that the scale factor to go from ABCD to EFHG is 3/4. Then using a dilation with a scale factor of 3/4, a translation, and a rotation, we can line up an image of ABCD perfectly on top of EFHG. Triangles are special since it is possible to determine whether or not they are similar by looking only at the angles. If two triangles share three corresponding angle measurements, then they are similar. In fact, since the sum of the angle measures in a triangle is 180 degrees, two angle measures determine the third. Hence, for triangles, all that is needed to deduce similarity is having two corresponding angles with equal measure. Students will use what they have learned about similar triangles to define the slope of a line. A slope triangle for a line is a triangle whose longest side lies on the line and whose other two sides are vertical and horizontal. Here are two slope triangles for the line L. For lines, it turns out that the quotient of the vertical side length and the horizontal side length of a sloped triangle does not depend on the triangle. That is, all sloped triangles for a line have the same quotient between their vertical and horizontal side, and this number is called the slope of the line. The slope of the line L, shown here, can be written as 6/8 from the larger triangle, or 3/4 from the smaller triangle, 0.75, or any other equivalent value. By combining what you know about the slope of a line and similar triangles, you will begin writing equations of lines, a skill that you will continue to use throughout the rest of the school year.